Okay, in this particular problem, we're going to look at how we identify acids and bases, Lewis acids and bases in reactions. So in general, we have three different types of acids or three different types of bases. These are different categories of how we think about bases and acids. The first is called the Arrhenius, the second is called the Bronsted-Lowry, and the third is called Lewis. The Bronsted-Lowry model is based on the idea of transferring a proton, a hydrogen ion, from the acid to the base. That is the definition. In Lewis acids and base, the Lewis acid accepts a pair of electrons in a new chemical bond on the product side. And the Lewis base provides an electron pair to form a new bond on the product side. So in the Bronsted-Lowry model, you're looking to see if hydrogen ions are being transferred. In Lewis acids and bases, you're looking to see if bonds are being formed. So here's an example. We're going to look at the first one, aluminum plus water to form the hexaaqua aluminum 3 ion. Notice that one of the reactants is in red. That is the one the question is asking about. Which of these four categories does the water, H2O, qualify to be? Is it a Bronsted-Lowry acid, a Bronsted-Lowry base, a Lewis acid, or a Lewis base? So again, when it comes to the Bronsted-Lowry model, all you're looking for is to see whether a hydrogen ion has been transferred. If you look at it, the water and the aluminum are separate. On the product side, they are together. There is no transfer of a hydrogen ion. Therefore, it is neither a Bronsted-Lowry acid nor a Bronsted-Lowry base. Okay, that's all you have to look at to see if a hydrogen ion was transferred. If you don't know what a hydrogen ion is, be sure to go back into chapter 4 of the ebook and read up on what a hydrogen ion is. The second possibility is that it's either a Lewis acid or a Lewis base. Here we're looking for new chemical bonds. And in order to identify new chemical bonds, you have to be able to draw Lewis structures. So let's look at this first one, the aluminum plus water, from the perspective of Lewis structures. So you have aluminum, and then you have 6 waters. So what I'm going to do is I'm going to draw the Lewis structure for water. Now, I don't need to do all 6 of them. I'm just drawing the Lewis structure. This is the Lewis structure for water. If you don't remember how to do Lewis structures, then you go back to chapter 8 in the ebook and read up on Lewis structures. It's all throughout chapter 8. Now, on the product side, what we have is aluminum, with water molecules attached to it. So here's what happens in terms of the Lewis structure. The water molecule, the oxygen specifically, provides an electron pair that forms a bond to the aluminum. So really what you have here is a new bond between the oxygen and the aluminum, and then you have that lone pair there. Okay, so that's one of the waters. But interestingly enough, there's 6 of them. So really what happens is each of these water molecules forms a bond to the aluminum. It's 3-dimensional. I'm not going to be able to draw all 6 of them in here, but you get the idea. Okay? All you need to do is ask the question, did we form a new bond between the 2 reactants? And we did. There was no bond here, but on the product side, there's a new bond. So there's definitely Lewis acid base chemistry going on. We want to identify which one's the acid, which one's the base. Now, in red, the water was in red. So here's what you do. The aluminum doesn't have any electrons. It's aluminum plus 3. Remember, aluminum has 3 electrons from its Lewis structure. That's the Lewis dot symbol, again, from chapter 8. But it's aluminum plus 3, so it doesn't have any valence electrons. So that means the bond that got formed between the oxygen and the aluminum came from the oxygen, which came from the water. So this is the Lewis base. And this one's a Lewis acid. Okay? So all you're doing is you're looking to see, did a new bond form between the two reactants? If the answer is yes, then we most likely have a Lewis acid base chemistry. The base is the electron pair donor. The donor is the one that has the electrons. So the lone pair there, that's the giveaway, that you have a lone pair. Notice the aluminum doesn't have any lone pairs, so that means it's the Lewis acid. It's the electron pair acceptor. Okay, so really, it's just the Lewis base. The water in red is the Lewis base. Let's take a look at the second one. Now, in the second one, if we take a look at it, you can see that the one that's in red is HClO, and that is called hypochlorous acid. It's part of bleach. The hypochlorous acid is reacting with trimethylamine, CH3,3N. The two products are hypochlorite, ClO minus, and the trimethylammonium ion. Now, if you look at what has happened, it appears as though the HClO, hypochlorous acid, has donated an H plus to the trimethylamine. See how on the product side it's NH plus? That means you have an extra H plus. It took an H plus from the HClO. So that's Bronsted-Lowry acid chemistry, acid-base chemistry. In Bronsted-Lowry, be careful, Bronsted-Lowry, the hydrogen ion is the important ion that's being transferred. The acid is the donor of the H plus. So the HClO is the one that's donating the H plus to the CH3,3N. So that means the HClO is a Bronsted-Lowry acid. And the CH3,3N, the trimethylamine, is the Bronsted-Lowry base. The base is the hydrogen ion acceptor. In this case, it's really the nitrogen atom, right? The nitrogen is the one that's accepting it. Now, let's look at it from the perspective of Lewis acid base chemistry. Okay. So you have HClO. And then you got your CH, oops, let's put this one in red, in black. And then your product side, you got ClO minus, and you got your CH3,3NH plus. Okay, that's a plus sign right there. That's an ion. Okay. All right, from the perspective of the Lewis acid base chemistry, you want to look for new bonds. So there's no new bond here. In fact, this thing is simpler than this one. It's actually lost an atom, so it hasn't formed any new bonds. But there is a new bond over here. Here it was just a nitrogen, now it's an H plus. That's a new chemical bond. So let's draw the Lewis structure here. We have an N, we have an H. The parentheses means there's 3 of them. So CH3. I'm just going to write CH3 like this. Sort of a shorthand, right? And then the whole thing is plus. So I'll just write out here, there's a plus sign there. Okay? This is the new bond. Okay? Now, the bond is a hydrogen attached to the nitrogen. It's actually a hydrogen ion. So, but we want to look and see what happened over on this side, on the reactant side. Notice I'm ignoring this because there's no new bonds in that one. I'm just looking at the one where there's a new bond. This new bond came from both of these reactants. So I'm going to draw out the Lewis structure for each of them. Again, I'm going to do this pretty quickly, but you know, Lewis structures are something you can review. I actually have a whole chapter of videos on how to draw Lewis structures. Really briefly, there's 1, 7, 6, so there's 14 electrons for this one. I've already got 4 here, so we'll make it 6, 8, maybe we could do 10, 12. No, it actually does that. That's 2, 4, 6, 8, 10, 12. That doesn't really work. It looks like we're going to have single bonds. Okay, there's your 14 electrons, right? 6, 7, 14, 2, 4, 6, 8, 10, 12, 14. Okay, now let's do this one over here. It looks just like the one on the right side. So you got nitrogen, CH3. For this one, I'll actually go ahead and draw it all out. That's fine. There's nothing really happening with the CH3s in the reaction. Okay, the key point is there's a lone pair there. Okay, that's the important aspect of this, is that there's a lone pair right there. So that lone pair is going to be used to form a bond with the hydrogen ion. So notice it's NH, new bond. Where do the electrons come from? The new bond is going to come from the reactant that has the lone pair. That's the key point. This lone pair is used for the new bond. And that's really what's happening in this Lewis chemistry, in this Lewis acid-base chemistry, is that lone pair. That's why you got to draw the Lewis structures to figure out where the lone pair comes from. The lone pair is right there. That's used to form the bond. So that means this one's the Lewis base, because the Lewis base is the reactant. Base is a reactant that has the lone pair for donation to form a chemical bond. Okay. Now, what about the other reactant? Well, if one of them is a base, the other one's got to be an acid. So this is your Lewis acid. Okay, the Lewis acid is essentially saying there's going to be a new bond between these two parts of the molecules, this hydrogen ion, H+, and this electron pair right there. So in this particular problem, they wanted this one, so it's the Lewis acid. Okay, if one's a Lewis base, the other one's got to be a Lewis acid. All right, so that right there is the second one. Let's take a look at the third one. So notice with that one, it's 2, right? Both are correct. It's not only is it a Bronsted-Lowry acid, it's also a Lewis acid, okay? By the way, you can't have a Bronsted-Lowry acid and not also be a Lewis acid, because anytime that you donate an H+, you're going to form a new bond. And so that means you'll also have a Lewis acid. Now, the third one is HNO2, which is nitrous acid. It's a weak acid, reacting with ethyl, looks like an ethylamine, C2H5NH2. That's called ethylamine. And you get the nitrite ion, and then you get the ethyl ammonium ion. So again, there's a new bond here. See the new bond? NH. So it's really H+ that's being transferred over. So again, this one had 2 hydrogens. Now it's got 3 plus a plus. That means it gained an H+, accepted an H+. That makes it a Bronsted-Lowry base. The well, that, you know, so that's true. But what I said earlier is something is, you know, it can't be a Lewis base without being a Bronsted. I'm sorry, let me put it this way. It can't be a Bronsted-Lowry acid without being a Bronsted-Lowry, without being a Lewis acid. Okay. So if you take a look here, this one is a Bronsted-Lowry base because it gained an H+. So that means it's also got to be a Lewis base because it's forming a new bond. The bond is between the nitrogen. See, it has 2, now it has 3. That means there's a new bond. The bond is between the nitrogen and the hydrogen. Where'd the hydrogen come from? Over here. Okay, so did the pair of electrons come from here, or did it come from here? And again, you'll see the patterns if you do enough of them, but there's only one answer to that. Okay. And the answer is, if you look, I'm going to draw out the Lewis structures here. This is HNO2. Okay, so this one should have 18 electrons. So 2, 4, 6, 8, 10. Oops, I'm sorry. 2, 4, 6, 8. 10, 12, 14, 16, 18. So there's your HNO2. And then you've got your ethylamine. So the ethylamine is C2H5. Again, if you don't know how to do Lewis structures, you're going to be kind of lost on this. So you may need to go back and really work pretty hard on how to draw Lewis structures, the octet rule. We're not giving you any particularly difficult ones. These are all pretty simple ones, but you got to know how to do Lewis structures. Okay. So then on your product side, you got your nitrite ion. I'm writing it out, but it's not particularly, there's a negative here. That one is not the one we're interested in because there's no new bonds there. But we are interested in the second one, which is C2H5. Oops. NH3. Okay. All right, let me just make sure I got this one correct. Sorry. This one should have 18 electrons. So 6, 8, 10, 12, 14, 16, 18. So that one's good. Okay. So notice you got this new bond here. Where did the pair of electrons come from? They had to come from here. Okay. They're not going to come from the H plus. H plus doesn't have any valence electrons. There's no electrons to be used. So that means the electrons came from here. So this is the Lewis base. Okay. So the one in red was that one, the ethylamine. So that one's got to be it. Okay. So for this one, not only is this a Bronsted-Lowry base because you now have an H plus accepted. It took an H plus, so that makes it a Bronsted-Lowry base. But it's also a Lewis base. We come back over here. Okay. This is also a Lewis base because the nitrogen forms a bond with the H plus using its own lone pair. So that makes it a Lewis base. This one would be the Lewis acid. The H plus doesn't have any electrons, so it can't be the base. It has to be the acid. So keep in mind, you got 2 categories here. You may even feel a need to review the basics of Bronsted-Lowry acids and bases. That's in chapter 4. I have videos on that. Just go into my YouTube and look up chapter 4, Lewis acids and bases is section 4.3. And then that's for Bronsted, sorry. And then for Lewis's, that's going to be in chapter 8, how to do a Lewis structure. That's in chapter 8 of the ebook. Okay. Good luck.